Now we are continuing with the analysis of the column, that is determination of load carrying capacity of the column. A reinforced concrete column is 400 mm by 400 mm in size and has effective length of 4500 mm, and the column is reinforced with 8 bars of 20 mm phi. Find magnitude of shape load that such a column can carry. Use M15 grade concrete and mild steel. Then what will be the magnitude of shape load if the effective length of the column is increased to the 8000 mm? So in this problem, so we have to carry out the shape load carried by the column. If the effective length of the column is equal to 4500 mm, that is the first case. And in the second case, what they are doing, they are increasing the effective length of the column is to the 8000. In that case, what is the load carrying capacity of the column you have to determine. So first one, so width of the column will be given 400 millimeter, then depth of the column is also equal to 400 mm. Then the M15 grade of the concrete is given and mild steel is given, that is materials are given. So after referring the IS 456, we are getting the permissible stress in concrete under direct compression is equal to 4 Newton per mm square, and similarly permissible stress in steel is equal to 130 Newton per mm square for the mild steel. Now if we have to first case number 1 is shape load carried by the column if the effective length is equal to 4500 millimeter. So L effective is equal to 4500 millimeter. Now first we have to decide whether the given column is short column or the long column. Then L effective, then we have to go for the ratio of L effective divided by least lateral dimension of the column. So L effective is 4500 divided by 400. So we are getting this ratio is equal to 11.25. So this ratio will be less than the 12. It means that given column is to be a short column. The next step you have to go for the calculation of the area of the steel. So this area of the steel is nothing but we have to number of bars into area of the 1 bars. Here the 8 bars of 20 mm diameter steels are to be provided. So 8 into pi by 4 into 20 square. So 8 is number of the bars and this will be the area of the 1 bar. So we are getting the area of the steel provided is 2513.27 mm square. Once we are getting the area of the steel, then we have to go for the gross area of the column. This gross area of the column is equal to 400 multiplied by 400. So we are getting the gross area of the column, and which is equal to 16000 mm square. This is the gross area of the column. Then we have to calculate the net area of the concrete, that is actual area of the concrete, and which is equal to AC, and which is equal to gross area minus area of the steel reinforcement. This is the area of the steel reinforcement, and AG is your gross area. So area of the concrete is equal to this value minus area of the steel, that is area of the steel is 2513.27. So after simplifying this one, we are getting the net area of the concrete is 157486.73 mm square. Then we have to go for the shape load carried by the column, which is directly given by the formula. P is the shape load carried by the column, which is equal to sigma cc multiplied by area of concrete plus sigma sc into ASC. So sigma sc is nothing but the direct stress in concrete under compression. AC is the net area of the concrete. Sigma sc is nothing but the permissible stress in steel, and ASC is nothing but the area of the steel reinforcement. So after putting this value, so 4 multiplied by 157486.73 in plus 130, that is the stress in steel, into area of the reinforcement, steel reinforcement provided in the column. Then we are getting this P, that is load carried by the column, which is equal to 95672.02 Newton, and which is equal to 956.67 kilonewton. So this is the shape load carried by the column. So this is regarding to the load carried by the column when the effective length is equal to 4500 millimeter. In the second case, what happened? The effective length of the column is to be increased. The effective length will be the 8000 millimeter. So again we have to go for the whether we have to decide whether the given column is to be a short column or the long column. For that we have to take the again ratio L effective divided by B. So L is nothing but the effective length of the column, which is equal to 8000 divided by least lateral dimension of the column, which is equal to 400. So after simplifying this, we are getting this ratio is equal to 20, which is greater than the 12. So it means that the given column is to be a long column one. Hence in case of the long column can be easily buckles. So load carrying capacity of the long column will be the less as compared with the load carrying capacity of the short column. So for that we have to go for the reduction factor. So you have to calculate the reduction factor, that is CR, and which is given by the formula CR is equal to 1.25 minus L effective divided by 48B. So 1.25 minus L effective is 8000 divided by 48 into least lateral dimension, that is 400. So after simplifying this, we are getting this ratio, that is the coefficient, reduction coefficient is equal to 0.833. So load carrying capacity of the given column is given as load carrying capacity is equal to P into load carried by the short column into reduction factor, that is CR. So load carried by the short column is equal to 956.67 into 0.833. So after simplifying this one, we are getting this load carried by the column when the effective length is equal to 8796.90 kilonewton. So this is the load carrying capacity of the column when the effective length is to be 8000. So this is the regarding to the one problem. Then you have to go for the another problem, that is, now consider the next one. A column of 3 meter long having size equal to 300 mm by 450 mm in a section, and it is reinforced with 8 bars of 16 mm phi, and the column is effectively held at position and restrained against the rotation at both ends. Find the shape load carried by the column. Use M20 grade concrete and Fe415 steel. So in the given problem, what happened? The length of the column is given and the support conditions are given. It means that the column is effectively held at position and restrained against the rotation. So first you have to write down the given data. So what is the given data? Dimensions of the columns are given. B is equal to, that is, width of the column is 300 mm. D is the depth of the column, that is 450 mm. L is the length of the column, which is equal to 300 mm. So again the M20 grade concrete is given and Fe415 steel is given. So you have to calculate the constant, material constant, that is sigma cc, which is equal to 5 Newton per mm square, and sigma s is 190 Newton per mm square. This value we are getting from the IS 456 2000, page number 81 for the sigma cc and page number 82 for the sigma sc. From that we are getting the value of the permissible stress in the material. Then we have to go for the calculation of the effective length of the column. So for that again we have to refer the IS 456 2000, table number 28, page number 94 will be gives the how to calculate the effective length of the column. So for that we have to refer that table. So in that case we have to use the refer the condition column is effectively held at position and column is effectively held at position and restrained against the rotation at both ends. That case we have to refer. After referring this case, we are getting L effective is equal to 0.065 times length of the column. So after simplifying this, we are getting the effective length of the column is 1950 millimeter. Now we have to find out whether the given column is to be short column or the long column. For that again we have to calculate the ratio L effective divided by the B. So 1950 divided by 300. So this, after simplifying this one, we are getting this ratio is equal to 6.5, which is less than 12. It means that the given column is to be a short column. So to calculate the load carrying capacity of the short column. Now first step you have to calculate the area of the steel reinforcement provided in the column. So area of the steel reinforcement is nothing but the number of the bars multiplied by the area of one bar. So here the 8 bars are to be provided, multiplied by area of the one bar, that is pi by 4 into 16 square. After simplifying this one, we are getting this area of the steel is equal to 1608.50 mm square. Then we have to go for the area of the concrete, that is net area of the concrete, which is equal to gross area of the section minus area of the steel reinforcement provided in the column. So gross area of the column, that is, which is nothing but the 300 multiplied by 450, which will be gives the gross area of the column, that is the dimension of the column, minus area of the steel reinforcement, that is 1608.50. After simplifying this one, we are getting the area of the concrete, and which is equal to 133391.5 mm square. This is the net area of the concrete. Then we have to go for the shape load carried by the column, and which is given as P is equal to sigma Cc AC plus sigma SC into AC. This is the formula for finding the SAP load. Now permissible stress in the concrete is 5 multiplied by the net area of the concrete plus permissible stress in the steel reinforcement, that is the 190, that is we are using the Fe415 multiplied by the area of the steel reinforcement. After simplifying this one, we are getting the SAP load carried by the column, which is equal to 972.572 Newton, and which is nothing but the 972.572 kilonewton. So this is the SAP load that can be carried by the given column. So this is about the one of the example. Now we have to go for the another example with the different conditions are given. So determine the SAP load of the column of 450 mm in diameter, reinforced with 1.5% of longitudinal reinforcement. The column has to be unsupported length of 3.2 meter and the column is effectively held in position at both ends but restrained against the rotation at one end. Use M20 grade concrete and Fe415 steel. So in this problem, the circular column is given. The last two problems are regarding to, one will be the square column, another will be the rectangular column. In that case, we are calculating the load carrying capacity of the column. So here the circular column is to be given and the diameter of the column will be the given, that is the 450 mm, that is the diameter of the column. And again the length of the column, that is unsupported length of the column, is nothing but the length of the column is given, so which is equal to 3.2 millimeter. And again the material given are the M20 grade concrete and Fe415 steel. So again we are referring the IS 456. We are getting the sigma Cc is equal to 5 Newton per mm square and sigma Sc, which is equal to 190 Newton per mm square. Now what we have to first do, we have to first calculate the effective length of the column. Again for that we have to refer the IS 456 2000 table number 28 page number 94 will be gives the how to find out the effective length of the column. Here the column is to be effectively held in position at both ends but restrained against the rotation at one ends. That case we have to refer. After referring this case in the IS 456, we are getting L effective is equal to 0.80 L. This is the effective length of the column when both ends are effectively held in position but one end is restrained against the rotation and other is not restrained against the rotation. In that case we are getting this L effective is equal to 0.80 L. So after simplifying this one, we are getting the L effective is equal to 2560 millimeter. Now gross area of the column is given as gross area is nothing but Ag, which is equal to pi by 4 into diameter of the column, that is circular column will be there, that is 450 square. So after simplifying this, we are getting the 159043.12 mm square. This is the gross area of the concrete. Now here again the area of the, instead of given the number of the bars, here the area of the steel will be given in the percentage of the gross area of the column. So here we are providing the longitudinal reinforcement as 1.5% of the gross area of the section. So the area of the section will be the 1.5 times gross area of the column. So area of the steel reinforcement is equal to 1.5% of gross area of the column. So here ASC is equal to 1.5 divided by 100 into gross area of the column will be the 159043.12. So after simplifying this one, we are getting the reinforcement provided in the steel reinforcement provided in the column. So we are simplify this one. So we are getting the 2385.64 mm square. This is the area of the steel provided for the given column. Then next step we have to calculate the net area of the concrete. That is net area of the concrete is nothing but the gross area of the column minus area of the reinforcement provided. So this is the gross area of the column which are calculated in the previous step minus area of the steel reinforcement, that we are getting 2385.64. After simplifying this one, we are getting the area of the net area of the concrete is 156657.48 mm square. So in this case the circular column is to be provided. Suppose if we are providing the helical reinforcement in this circular column, in that case the load carrying capacity of the column will be increased by the 5%. So we are getting the load carrying capacity is equal to 1.05 into sigma Cc into AC plus sigma SC into ASC. So this is the load carrying capacity of the, that is the short column, and this 5% will be increased due to the helical spiral reinforcement provided, that is helical reinforcement is to be provided one. So this load carrying capacity is equal to 1.05 into stress in the concrete, permissible stress in the concrete, that is the 5 into this one area of the concrete, and this 190 into, that is the area permissible stress in the steel, multiply by the area of the steel reinforcement. After simplifying this equation, we are getting the value of load carrying capacity of the column, which is 1298386.95 Newton, and which is nothing but the 1298.386 kilonewton. So this is the load carrying capacity of the given circular column.